So hello and good day to everyone. Pleasure to welcome you all. It is my pleasure to welcome you all to the webinar entitled Roles of GIS in Civil Engineering. By the end of this webinar, I could guarantee that every participant will gain at least one new knowledge, as well as sharpen your current knowledge regarding the 3D GIS technologies and its application. For today, our main event, which is the presentation and a live demonstration, will be presented by our two main speakers from SuperMap Asia and Oceania Center. Along the way, if you have any curiosity or question that you would like to ask, you may type it in the chat box and it will be answered by our presenter as soon as possible. So before we start, we will watch some introduction video regarding the SuperMaps and its technology. Okay, so as shown in the video, SuperMap has 5 main key technology which called BDC, where this is the acronym for the Big Data GIS, AI GIS, 3D Dimension GIS, Cloud Native GIS, and lastly, Cross-Platform GIS. This 5 main key is what we from SuperMap established for GIS platform software. So before we start, if you want to, you can or you may introduce yourself in the chat box. So we will look deeper regarding the GIS technologies and its application with our speaker, Ms. Anis Farhana, our business development from Asia, SuperMap Asia and Oceania Center. Ms. Anis, the times and floor is all yours.
Okay, thank you, Shafika. So let me share my screen. Okay, so good day, ladies and gentlemen. So now that you know about SuperMap, so right now let me expose to you on the rules of GIS in civil engineering by using SuperMap. Okay, so let's start with our first application, which is Smart City by using BIM and GIS technology. So first of all, what is BIM? So as we all know, BIM stands for Building Information Modeling. So it takes the relevant information data of building engineering project as the model basis. So it records the geometric and attribute information of building components in detail and accurately and present it in the form of 3D model. So now let's take a closer look on how is BIM model represented on GIS platform. So as we all know, there are many BIM software, but the 5 formats are different. So in order to break through the bottleneck of BIM data access to the GIS software platform, so GIS software has developed data export plugin for BIM software, such as Bentley, Autodesk Civil 3D, and Tekla. So meanwhile, it also supports import of the interchange format IFC, CTGML, and others. So some GIS software also has a deep strategic cooperation with BIM-related companies. So now it supports the direct opening of some related BIM data in the form of data sources. So from this, the close connection between BIM and GIS data is achieved. Okay, so this is the example of BIM data that is being displayed in the GIS platform. So we make sure that we fully preserve the BIM features, data structure, and also the expression effect after importing to GIS platform. Now let's take a look on some operation which can be done if we integrate BIM and GIS technology. So here I will show you some capabilities of GIM platform to provide BIM model editing, group management, component query, model clipping, and others. Okay, so the first one, in GIS platform, we can perform editing of the imported BIM model. So for example, we can move sub-objects of the BIM model into different locations using the model offset. And also we can edit the texture of the BIM model inside of the GIS platform as well. So another capability, inside of the GIS platform, the user can check the BIM model information for each object to see the attributes or the properties inside of the object in the BIM models. And then next, BIM model also can be grouped for better organization. So you can see on this figure, on the layer management here, the BIM models are being grouped into different sections for a better group management. So we can also display the BIM model using the cut sectioning view. So in this figure, we draw a box for the cut sectioning to see the model inside of this box only. Meanwhile, GIS platform also can provide dynamic simulation function by setting the display and hiding of BIM model. So in practical application, the process of building construction construction can be simulated, and the building production can be viewed based on the construction progress and also time of the construction. Okay, now after showing the capabilities of BIM and GIS integration, we are moving to the next outline of this presentation, which is city information modeling. So before that, let me show you this illustration. So I have a city environment overview, and I have some issues that I want to share with the audience. So these issues are starting with the question, how if? How if I want to place BIM models at the actual geographic location? How if I want to analyze any conflict of pipeline assets? How if I want to understand the surrounding areas of the building and the other issues as well? Okay, so now those questions can be answered using the integration between BIM and GIS. So BIM and GIS can play a greater role in the city level. So let us imagine this. So buildings are cells of a city, and then BIM and GIS can manage the cells as well as the environment around the cells and various connection network to make up the CIM. So CIM stands for City Information Modeling. It is an organic synthesis of 3D urban spatial model and urban dynamic information. So it can perform urban information management platform, including BIM, geospatial data, and IoT, Internet of Things data. And it is the future development trend of BIM and GIS. So based on CIM, we can promote smarter cities to a higher level. Okay, so the data types include in CIM are diverse, including BIM, oblique photography, laser point cloud, image, vector, and real-time dynamic IoT data, and etc. So we need to solve the problems of multi-source data integration, accurate matching, unified management, and so on. So the GIS platform can provide CIM with data access, integration and matching, management and analysis, as well as high performance rendering and multi-terminal display of massive urban data. Okay, so in CIM, we need to match multi-source format data. So it also includes to match BIM data with multi-source data. So with the continuous accumulation of large-scale 3D data, the integration and matching of multi-source data becomes particularly important. So in this figure, it shows that BIM can be integrated with 3D data, photographic data, water surface data, and video data. Okay, so this figure is showing an example of CIM platform based on the BIM and GIS engine. So you can see here, the BIM model is overlaid with many kind of data format and also base map. So inside of this platform, we can also perform some analytic functions. So you can perform the power consumption gas consumption, water consumption, and also the price of each level of the buildings and etc. Okay, so there are many typical BIM and GIS industry solution and application cases, including urban and landscape planning, architectural design, 3D cadastral map, environmental simulation, thermal conduction simulation, indoor navigation, and so on. So where actually BIM and GIS is applied? So BIM and GIS is applied on the entire life cycle of construction, including the planning stage, design stage, construction stage, and maintenance stage. So let's discuss one by one. So the first one is planning stage. So let's take a closer look on it. So the planning stage can include site analysis, which provide the evaluation of site condition and characteristic. And then the second one, the architectural programming, and the last one, project demonstration. So it is necessary to combine 3D GIS and put BIM in the big scenes, such as oblique photography, to demonstrate and compare the architectural schemes. Okay, so this is the implementation of BIM and GIS in planning stage. So the urban design refer to the design and organization of urban external space and physical environment for a specific urban construction goal. So BIM and GIS provide urban design with powerful spatial data management, analysis, and visualization capabilities. So in particular, with the development of 3D GIS, it can provide strong capability of multi-source 3D data integration, 3D data operation and analysis ability, flexible rule customization ability, beautiful scenes, and provide services for urban design. So the next stage we can be applied is the construction stage. Using BIM and GIS, it can perform construction schedule simulation and construction organization simulation. So this is one of the project which implement BIM and GIS in the construction stage. So it breaks through the technical difficulties such as precise matching in centimeters between BIM and GIS data and real-time rendering of million-level BIM data. So using of BIM, GIS, IoT, big data, intelligent, mobile communication, ERP, and other key technology, it provides user with project management, video management, Internet of Things platform, big data platform, service management, and other business system. So all of these realize the elaborate management of construction projects and intelligent management about the environment, safety, quality, and progress of the construction site. Okay, so the last type which can be applied BIM and GIS technology is the maintenance stage. So now I am showing you one of our project which implement BIM and GIS in the maintenance stage called as BIM operation platform. So the operation platform of Shanghai Center developed based on the SuperMap GIS platform and integrate with BIM, IoT, big data, mobile internet, AI, and other new technology to realize the fine control of the Shanghai Center. So you can see on this figure, there are several activities which can be performed in this BIM operation platform, such as model show query, emergency simulation, closed model properties, and others. So this is another project which implement BIM and GIS in the maintenance stage. So it is a river 3D visualization information platform. So SuperMap has been involved in this project with research and application of digital management platform for the whole life cycle of hydropower in river basin. So in this platform, BIM and GIS technology are integrated by SuperMap to realize the multi-dimensional management of water conservancy facilities. So the platform mainly provide 3D visualization, emergency aid decision making, safety monitoring, and other functions as well. Okay, so now we have arrived at the last part of this smart city application. So mostly I am going to show you some project video which implement BIM and GIS. So the first one. So in this operating platform, the flow queries can be made and we can choose different model system in that flow, such as the water supply, the heating, and also security system. So in each system, we can click to view the KPI information of independent devices or search and also locate them. And then in the equipment management inside the platform, we can set up a maintenance cycle so that we can find the equipment which need to be repaired without any difficulty. And then also this platform is equipped with the emergency management as well. So it can perform evacuation simulation when there is a fire emergency. And then at the same time, the platform can show the working condition of emergency equipment as well. So the platform also has a lot of other management functions such as asset management, security management, and space management. Okay, so this is the last video I want to show you. So this is the geo-design platform for town planning in Hong Kong. So this is the 4 minutes video. So please enjoy. Okay, so let's move on to our second application for civil engineering, which is 3D GIS for urban planning. So now, why 3D? Because the world is 3D. We live in the world that is in the 3D scenes. Okay, so these are the benefits that can be obtained by using 3D GIS technologies. So we can help 3D can help to display the true world better. We can solve the real problems. We can display indoor and underground space and do the automatic management. Okay, so this is an example for integrating 2D and 3D data. So as we all know, usually the hill map will show in a numbered contour. And then with 3D, you can view the hill with the real shape. And then from there, you can also combine with other 3D data such as the underground pipeline, the building, road, and many more within one platform. So this is a few examples for urban planning system. So you can do the above ground space verification, above underground elevation, above underground building range, and regulation range box. From here, you can do further decision system like signal strength, categorization of buildings, height of buildings, uses of land, and etc. Okay, so now I want to talk about urban design rule that will be applied from GIS platform. Okay, so first rules construction is backline detection of building along the street. So the orange shows the line detection, and then the red color shows the building that is over the boundary. Okay, so the left side here shows the workflow to apply the urban design rules from using the tools in SuperMap GIS platform. And then the next one is we can help you to design the underground space that will not be out of coach. Okay, so this is another example to detect if the underground buildings are beyond boundaries or not. And then this one is the boundary line detection, is when you already have the specific area for the urban planning. So from here, we can help you to make sure that all the buildings is within the boundaries only. So you can set up the parameter here. Okay, so the white one is the boundary, the building is over the boundary. Okay, next is the height control analysis. Okay, so you can get directly the reading of the building height from the 3D volume model. Yeah. Okay, so next you can also do the sunlight analysis to calculate the sunshine duration of every household. So from the sunshine duration, you can further calculate the pricing of the houses and etc. Then this one is the line laying rate of street buildings. Okay, so here is the example of the 3D GIS analysis. So the first one is openness analysis, is related to how wide a landscape can be viewed from any position. So from here, the red one is the invisible one, and then the green one is the visible ranges. And then for view sheet analysis, so this function is used to identify all the visible and invisible ranges in the analysis area of a scene. So here is the point of view. So as you can see, the red one is the invisible one, the green one is the visible one. And then for the skyline analysis, this function will allow the generation of the boundary between the building tops and the sky from the observer point. Okay, so now I will share a few cases for urban planning. So in SuperMap, we already have planning templates to do the conceptual design quickly. So from here, you can calculate the gross floor area automatically. You can use the parameter to create building blocks in 1 minute. You can check the restriction automatically, use powerful 3D analysis, and many more. So I will show this one by one. So the first one is free drawing. So by using SuperMap, you can do the free drawing, which you can select any empty area. And then from here, you can define the base height of the building. And then you can also draw any shape of the buildings based on your preference and directly specify the height. And then you can also customize the color of the buildings and also the texture of the buildings. Okay. So we also support the direct import and display from another file format design, such as from shapefile or the CAD tag file. So and then after import to the GIS platform to this design template, so you can just directly do the further 3D analysis, such as the skyline analysis as shown in the video here. Okay, so this video show the design. You can specify the parameter of the building first. So as you can see here, you can specify how many level you want, the height of the buildings as well. Then you can also choose the tower type. And then after all that, you can just click to get the buildings that you had designed. Just specify the parameter. You can just click on the date and it will automatically generate it. So there you go, the design rule that you already applied for this urban conceptual design. And then next one is 3D GIS analysis. So this one will be shown during our live demonstration after this. So I will move on to our third application, which is smart water affair. So these are the list of analysis that we provided for water pipeline solution. So it includes pollution analysis, pipeline distribution, connectivity checking, shortest route search, and so on. So first, I want to show you our cases for pumps operation monitoring. So this system uses workflow technology to achieve approval of construction land management process information. So it includes application, joint hearing, approval, filing, fees, and etc. So this system connects Department of Planning, Farming Protection, land users, cadastral, and supervision to the land administrative departments at provincial, municipal, and country levels to achieve the approval management information. And then from the analysis as well, SuperMap can help in monitoring and control system of the smart water. So we can help you to do the water quality monitoring and alarming for different water parameters, the water quality parameters, COD, BOD, and so on. We can also have the water level alarming, and the contingency plan management, the editing, approval, and many more. So, and then we can also use mobile phone for the end inspection of the water supply network. So by using mobile phone only, you can do the query and allocation of pipe network data petrol report, processing, statistic, the trade view of the petrol, and many more. So in SuperMap, we will integrate the 2D drawing and the 3D design for the user to do the further spatial analysis as mentioned before, which is the collision analysis, the burst analysis, and so on. So this is the example of workflow to create the pipeline in the 3D scenes. So user can import the pipeline data in DWG format. So in SuperMap, we have the template for symbolization that you can select based on your preference. So it will automatically create into 3D. And then you can further generate the pipeline by adding the arrow, the T, cross, and etc. And then finally, you can generate the 3D building above ground to get the overall design for the smart water system, the unit, and the facilities as well. Okay, so this figure shows the example of the 3D design. So from this system, you can analyze the water usage or maybe the area that will be affected when there is a burst incident. So you can switch off the pipeline that is or is not affected, and many more applications in the smart water performance management system that can be achieved. And then we also have the query and statistic system. So the system can query and locate the attributes of pipeline, such as the category, the pipe diameter, the material, the burying date, characteristic, and facilities, and can also make statistics and report according to these attributes. So we also integrate another technology, which is VR, virtual reality. So from here, you can get the direct view of the pipeline by using the VR. And then we also use the big data technology. So from here, you can see that this video show the big data of pipeline, which is quite massive, and that can be displayed in SuperMap smoothly. You can just go smoothly this view. Okay, so the last application for today is 3D GIS and BIM technology for transportation. Okay, so SuperMap GIS provide designer with 3D spatial analysis capabilities during the design process. So after quickly importing the BIM design model into the GIS software platform, so through the mosaic of BIM data and terrain data as shown in the figure, the road model can be combined with high precision. So the accurate fusion of the terrain it is necessary to achieve the correctly display of the road BIM model on the ground. So with the accurate fusion of the terrain and BIM model, user can calculate the area that will be affected from the design plan in the real time. You can also determine the population or land, quick route selection, and etc. So with BIM as well, user can do the further statistical analysis from 3D spatial analysis, such as the buffer analysis here as shown in the figure. So for using the buffer analysis, you can calculate or determine the affected area from the road design schemes. Okay, so when the final design plan is determined, the BIM model is imported into the GIS platform along with other multi-source data such as the terrain, images, steel, and etc. to fully and comprehensively display the design plan to be shown for the construction companies. So for your extra information, SuperMap GIS support comprehensive scene optimization and service publishing of multi-source data. So design solution can be provided to relevant parties for online browsing and inquiries through online methods. And the 3D scene can also be browsed through mobile phone as well. So the BIM model data in major transportation engineering projects can usually achieve component level accuracy. So SuperMap GIS support functions such as loading, display, analysis, and calculation of a large number of defined model objects and can associate huge and complex engineering construction data with construction objects. So all construction drawings, plan, supervision process data, material supply data, and etc. can all be bound to specific facility components in BIM data. And then the query, statistic, and visual rendering of this construction information can also be realized in a 3D GIS scene. So next, SuperMap also support the dynamic rendering of BIM model. So by combining BIM construction and project progress information, the entire project model can be rendered and displayed according to different construction progress so as to help user understand the overall project progress intuitively. And through progress animation, we can dynamically display the changes in the construction progress within a certain period of time. So with the multi-source data fusion capability of SuperMap GIS, the various detection information and BIM models can be analyzed and displayed in a 3D scene. And the state of traffic facilities can be accurately analyzed through the 3D spatial position relationship, and the impact of various disaster information on traffic can be predicted to realize the facility intelligent transportation, nutrition, and protection as well. So this means that this one is the real-time dynamic traffic supervision in a 3D GIS scene. So this means that we can also integrate BIM, GIS, and IoT technology as well to get the real-time reading, which can be displayed in both web and also mobile phone as well. So it's the in-depth application of the new technologies such as big data and artificial intelligence in the transportation industry. The combination of 3D GIS technology will promote the evolution of 3D GIS technology in the direction of intelligence and promote it to become an important technical means of the transportation information department. So this is the end of my presentation. So you had been exposed to smart city application from BIM technology, urban planning that is strongly related to the 3D technology, and then the smart water affair and the transportation that can significantly combine the multi-source data with BIM, GIS, and also the IoT technologies. So other than that, SuperMap also support other civil engineering applications such as environmental, site analysis, infrastructure, CAD integration, structural, and etc. So you can let us know if you are interested to know more in all of these applications. So thank you all for listening. So please be anticipated to our live demonstration after this. Thank you.
So thank you, Ms. Anis, for insightful details about application of 3D GIS in civil engineering. There is an advertisement. Actually, we are looking for a new partner and reseller to expand the business. And if any of you want to know more about this, you may contact the following email address as shown. We also have SuperMap individual package for those individuals that are interested with our software, where this package include the SuperMap iDesktop and iTablet. If you have any inquiries, you may contact anis@supermapalayas@gmail.com or anis@supermap.com. So Miss Anis, there is one question, but it's just a simple question. Will you share this slide to the participant later?
Yes, we will share all the materials and also certificate and the trial license after within 7 days, 7 working days after this webinar.
And there is another one question from Abdullah Haris. Hi, is the technology only capture those above ground level? How about underground services?
We also have the underground services. So it depends on what kind of data that you have. So as long as we have the data, we support the import data to our platform, and then we can do the further analysis of further services on your data.
Okay, thank you, Ms. Anish. So we will have a short break for 5 minutes. But before that, I would like to share the evaluation and feedback form where we will set your suggestion and feedback to improve our future webinar. You may scan the QR code shown in the slide, or you can click the link that I shared in the chat box. Thank you. So hello everyone. I hope you are there and welcome back. And I hope everyone are feeling good and fresh after the short break, and we can start with our live demonstration. For the last presentation, which is our live demonstration of 3D GIS by using SuperMap technologies, will be presented by Ms. Chin Zhang from SuperMap Asia and Oceania Center. Ms. Chin, are you there? The time is all yours now.
Yes, I'm here. Can you hear me?
Yes, clearly.
Okay. Good morning, everyone. This is Chin speaking. Nice to meet you all. And the next section, I'm going to demonstrate some live. I'm going to do some live demonstrations, and these demos are made by SuperMap products. So the first, let me share my screen first. So can you see my screen?
Yes, Miss.
Okay. The first example, it is a Frontier 3D plan in Thailand. This project it is about the 3D design for a tenant users, and this and all these demos are made from Revit. So firstly we imported the Revit demos to our SuperMap at desktop, and then we do a serious processing of these models, just like create cache or beauty or do some how to say, we firstly imported it into a desktop and then do some processing in a desktop, and then we export the models from a desktop by generating 3D caches. After that, we built a 3D WebGIS applications like this, and this project is developed by SuperMap iClient 3D for WebGL. So here you can see this is the models, and there are buildings, and we also end the vehicle on this project. And we can view these buildings. Firstly, we can also manage the layers. So here we can see there are several layers combined this whole project. Firstly, forest pavilion. Here we can see that it is this one. And the wisdom frontiers. Here we can see this is this building. So we can control the visibility of each layer. And this Six Sense Hotel. So here we can manage all these layers on the 3D website. And then we can also do some measurement, just like we can measure the distance on the ground. So here we want to know the width of the road. Here we can draw a point and draw another point. So here we can get the width of the road, and also you can measure any object on these 3D things. Here we can also measure the error of the object, just like the buildings. Here we can draw 4 points of the buildings. Then here we can get the error of these buildings. As well as we can also measure the height, just like we can measure the building of this. So here we can get the horizontal distance and the here we can see the height and all these parameters we can get here from here. And another way we can also add flag managers. So here we can view these things automatically on the ground. We can view these things like this. You can make the fly route and the fly files to the website, and then you can view these things according to your fly route. So it's here. Also, we can define varieties of view angles to view these things. And then also you can stop or begin by the Control tab. So let me stop it. And or we can also query the information of the objects, just like we want to know the old hotels information. Here we can query the information of this buildings. Here, like this one, this is the wall of the buildings, and also I think this is the floors. Yeah, and this is the floors. And this is the curtain panels. So you can query the informations and of the buildings. And what's more, we can also design on the website, just like this. Here we can add a chair. Just like this one, we can add a chair here, and also we can rotate it. We can rescale it like this, and here we can also add the trees. And the other trees. This. We can also add garbage. Let's please. Okay. Oh, yeah, here you can see. Yes. Yeah, and we can add a light. Also, we can scale it. So here we can add the design. Or we can add the design part on the web terminal. And what's more, Here we can do some spatial analysis, just like the visibility analysis. Let me show you. The visibility analysis, first we choose one viewpoint, just like this one, and then we add another viewpoint, just like this one. Here we can see that from these two points, from this point to this point, it is visible from this point to this point. But if we add another point, and just like this one, here we can say the red part, the red line means here from this point we can only see from this point to here, but from this point and to this point it is not visible. So here we can help you to design the help your urban design. And also the view shared analysis. We draw a view shared analysis. We first draw a point, and we can draw an error. So here we can say that the red error means from this point we can't view these red errors, but from this point we can view the green errors. Here we can also adjust the parameters to change the view part, the laser aspect. We can change it, and also here we can do the scanline analysis. We can extract the scanline. Here we can see the lines here. This is scanline, and we can also display the 2D scanlines like this. And also draw a limited body. Yeah. And then here we can get the limit body and the scanline error. Like this from this is about the scanline. And also the shadow analysis. Here we can do the shadow analysis like this. Here we can see that we can check the shadow ratio. And click one. Let me close this. Here we can see the shadow ratio of each part. So also all this spatial analysis help you for the urban design or city design to better design your city, and here. And also we can clip because we can do the clip. Just like if you want to view the inner part of this building, you can do a clip. Here we can adjust to the length, the width, or the height. We can rotation it. Then here we can view the inner part of this building. Like this. Yeah. This. Actually, here we can also let me show you whether it is available. Yeah, I think this is about this project. The next, I'd like to to show you another example. This is also a beam model. Here you can see, and as you see here, we can also control the layers the layers of visibility. Here also, here we can control the structure of the windows or the wall, floor. So, and also here I want to just now I saw somebody asked us whether we can demonstrate the object underground. Here, let me show you. This here we can either need to show the object underground also on the desktop terminal or the website terminal. Here I show you the website terminal. As you see here, there is a part of the building underground. If we don't make the ground visible here, we don't know whether there is an object underground. But if we end a curtain view like this, here we can see the underground part of this building, and also we can check the information of the underground part like this. And also here we can also do excavation, just like we can draw an area, and then here we can see the underground part of. Let me draw a part like this one here. Here also, this function can also help you to view the object underground like this. So then let's go to another example. This is about the geological body. And also we know that the geological body is also underground. So here we can do some do some operations on the geological body, just like the exploring, like this. If we control this, then here we can see each part. We can see each part of the geological body by exploring like this. And what's more, we can also excavate the geological body, just like here we can draw an area, and then we can do the clip. Then we can see the inner part of this geological body, and also do the excavation, just like this. Then here we can see the inner part of this geological body, and also we can display the draw pose. This. So all these operations can help you to better view the geological body, as well as we can view the profile of geological body. We can draw several lines, and then we can view the profiles of the geological body. So I think that's all for my demonstration. I demonstrated some 3D applications and geological body applications. If you have any question, you can put your questions in the chat box. So thank you.
Okay, so now we will go to, thank you, Ms. Chin, for your insightful details regarding the 3D GIS and the live demonstration. For now, we will go to the closing remarks, which is, we will have Muhammad Aziz, which is the president from EAGE UKM.
Good morning, everyone. First and foremost, I would like to express my appreciation to the speakers and panelists for their valuable contribution to our webinar today. My deepest gratitude goes to all who attended and helped to make this hearing and learning from these speakers and panelists, as well as the audience, has educated me personally, and I'm sure it educates all of us here also on how SuperMap application as a GIS tool can help engineering, especially in geotechnical perspective for me. And I am certain that the takeaway from this event will further deepen our knowledge and stimulate our skill for the future, especially for the geospatial skill. Throughout this event, what I understand that they highlight the opportunities and benefits that the SuperMap app has already brought, especially for the GIS industry, geospatial industry. And before I end my closing remarks, I would like to convey a special thanks to the audience, especially outside from the EAGE, outside from the EAGE UKM student chapter, to able to join our event today. And my deepest thanks, of course, for the panelists, Shafika, and our presenter, Miss Anis and Miss King, for their contribution for this webinar. So that's all from me. Thank you.
Okay, thank you, Haziq.
You're welcome.
Okay, last but not least, I would like to inform that our company would like to do more webinar and workshop collaboration with more university or any company to introduce to you about SuperMap software and its advanced application, where from this session, every participant will receive a certificate and a free trial license, as well as the opportunity to learn GIS technologies such as AI, AR, deep learning, and many more. We will also have the live demonstration in our webinar, where all of this will be provided by us without any charge. If you are interested or have any question that you would like to ask, you may email to our business developer, anis@supermapalliance@gmail.com or anis@supermap.com. So we're already at the end of the webinar, and I would like to thank everyone for your time and willingness to join this webinar session. And I really hope that we could meet in another session. Thank you so much, everyone, and have a nice day ahead. Stay safe.